Okay, hello everyone. This is the SIG, Kubernetes SIG cluster lifecycle cluster API office hour meeting. Today is Wednesday, 7th of April. And before starting, a few info about the meeting etiquette. So first of all, use your raise hand feature of Zoom. Whenever you want to talk, I will do my best to, and also to look at the chat. The raise hand feature should be near or under the reaction button in Zoom. Second, if you have a topic that you want to talk about, feel free to edit the agenda. The agenda is in this document. I've pasted in the meeting chat the link to this document. And if you don't have access to this document, please join the SIG cluster lifecycle mailing list, and you should get access right immediately. Okay, so let's go down to today's agenda. Thank you for adding your name to the attending list. And I will start with two quick PSA. First of all, thanks to Shyam. Now in Cluster API, we have upgrade test and conformal test for 5 Kubernetes version for the workload cluster. So we're starting from stable -3, which currently is Kubernetes version 1.17. And we are testing upgrades up to the current master in Kubernetes, which is 121 RC something. So thank you, Shyam, for this. This is really helpful, and it will take some time to stabilize those tests, but they are really useful. Second PSA, also regarding test and test improvement, a big kudos to Stefan, which is helping in doing some improvement to our test. So he added a JUnit report for the unit test in pre-submit and periodic jobs. And this is quite impressive to see that we are running more than 2,000 tests for each run. Second, he incremented the logging for CapD in our end-to-end test. And thanks to these additional logins, it was capable to find a very subtle error in kind, which was causing many flags in our end-to-end test. And now the PR for fixing this is already measured in kind, and we will pick up the changes soon in Cluster API. So really thanks for this work, and I hope that when the change will be merged in copy, the signal will be much more stable than now. And for the next PSA, up to Cecile.
Thanks, Fabrizio. Yeah, I get to talk about the not so fun stuff of milestone grooming, but I just wanted to call out that we have continued doing some improvements to the milestone grooming over the last few weeks, and the release blocking label has merged and has been applied. So if you click on that list of issue, this is tracking the issues that are in the 0.4 milestone that are considered release blocking. So that means that we would want to wait or make an exception case by case for these if they're not in by 0.40. If you have anything that you're tracking that you think should be in here that's not currently in here, please flag it to one of the CAPI maintainers so we can make sure that it's being tracked in here. And if you see anything that is in here that you're currently assigned to that you're not currently working on, then now is a good time to check it back or unassign yourself if you don't have bandwidth, so that we make sure we have someone looking at it. So yeah, any questions on that?
Okay, Thank you very much, Cecile, for this work. The next one is still on you.
Yeah, and the next one is sort of related. This is just to circle back. Last time we talked about a deadline for merging proposals that are targeting V040, and we agreed on April 21st. There was an email to the discussion to the Google group, and no major objections were raised. So I think we're going to stick with that deadline. Let's circle back maybe next week to see if there are any proposals that are at risk. But yeah.
Great. Thank you very much, Cecile. I see Vince with his hand raised.
Just a quick question, like, do we want to do this for 040 proposals, and 04X should it just be open, right? Like,
Yes.
right.
Yeah, I think this is only targeting 040. Yeah. So especially breaking changes and anything that needs to be in the V1 Alpha 4 release.
Awesome. Thank you.
Okay, so if there are no more questions with regards to milestone grooming and deadline for V040, let's move on to Jason for the Tinkerbell provider demo. I'm really looking forward for this one.
All right, thanks. Can you go ahead and give me permission to share my screen, Fabrizio?
You should get permission now.
All right, I went ahead and added you back as a co-host in there.
Thank you.
All right, let me see. Let me find the right window now. Looks like it's no longer letting me just share a window. All right, I'll do it this way then. All right, so before I jump in, because I know not everybody's familiar with what Tinkerbell is, I just wanted to do a brief overview of that. Tinkerbell's basically an attempt to do a cloud native approach for infrastructure management and orchestration. So in addition to just being able to, provision an OS on an instance, you can also run like arbitrary kind of workflows against hardware that you have. And there's a few different components of Tinkerbell that help enable that. There's the core Tinkerbell workflow engine. This is what allows you to define the hardware that you want to manage with Tinkerbell. It also allows you to define what we call templates and workflows. Templates are basically a way that you define actions that you want to be able to run against hardware, and a workflow basically ties an instance of a template together with a particular instance of hardware to make it actionable. There's also a few different microservices that are involved in the entire system. The first one is Boots, which enables DHCP and Pixie booting services. There's also a Hegel metadata service. And there's also a worker component that actually runs on the infrastructure and reaches out to Tinkerbell and queries what workflows need to be run on that hardware, and actually is responsible for executing those workflows. So with that out of the way, let me go ahead and switch to a different window. All right, and let me go ahead and switch my camera as well. So hopefully you can see the camera. And what I have here is basically this box on the right here. That one's actually running the Tinkerbell services. And then I have 5 smaller boxes on the left that are actually configured in Tinkerbell for as hardware. So if I come in here and just Tink hardware, we can see that there are 5 devices in here. I did kind of cheat a little bit because you can define what the UUIDs of the hardware when you define them in Tinkerbell. So I know which physical box is based on the last letter of the ID. And so I have that running. I also have Cluster API running via Tilt, and the Cluster API Tinkerbell provider running now as well. So I have the hardware defined, and right now I don't have anything defined on the Cluster API side, but I do also have these Tinkerbell types, the hardware, the template, and the workflow. I also have CRDs for those actually deployed to the cluster as well. So if I do a kubectl API resources here, we can see that we have these this API group, Tinkerbell org, that defines hardware, templates, and workflows. And there's a couple of reasons for this. We built out what we're calling this shim layer to simplify the actual controller logic that we have for the Tinkerbell provider. But it also allows us to basically only let Cluster API access a subset of what's available in Tinkerbell. So if I did just get hardware here, we can see that there isn't anything in here by default. I need to actually specifically tell what pieces of hardware I want to run. And I do that with like this example right here. So let me just apply that real quick. And now that I've done that, let me go ahead. We can see that it was created. And if I describe it, we'll see a lot more information about that hardware. And I forgot to reset this from the last time I ran this demo. So there's a little bit extra data in here right now. But if I come in here, we can see in the spec, it was the ID that I defined. But here in the status, I have a little bit more information, and it's getting this information directly from Tinkerbell itself. So we can see that this hardware has one disk device at dev MMC block 0, and it has one network interface that's configured to allow Pixie booting and allow running workflows. We can also see that there's this metadata here as well. And this is metadata that we can define on the host and make available through the Hegel metadata service. In this case, this hardware had previously been used in this Cluster API demo, so it actually has kind of the user data that we would inject into a system kind of in there right now. But that said, the next thing I can do is go ahead and create a cluster, and I'll do a quick walkthrough of the template there. The other thing is I only created that one hardware because this hardware that I have doesn't have any type of management layer. So I only have the monitor plugged into the device that I call A, and I wanted to be able to show the screen. So that's the reason why I only applied one hardware device instead of all 5. So if I come in here to the cluster template, we can see this is basically just a standard cluster template. There really isn't much in here other than this provider ID. And this is just to allow us to work around the fact that there isn't a Kubernetes cloud provider for Tinkerbell, at least yet. So this is what populates the provider ID, gets it assigned to the node when it comes up, and allows to make the link between the node and the physical hardware. And that's really about it as far as custom things inside this template. Everything else is pretty blank. The first iteration of this, the cluster template actually included a lot of the bootstrapping instructions and everything, but we've updated things to be able to use image builder. So in addition to having Tinkerbell installed on that machine, the web server that's on that machine also hosts a pre-built image that I made with image builder for Kubernetes. I think it's 1.18.15. So when I deploy this cluster, I'm going to specifically deploy that version to Kubernetes so that it picks up the right image. So let's go ahead and apply that. And I'm going to copy and paste this because there's another thing that I need to change for my environment as well. So if I go back up to the command that I ran, I've overridden the pod cider here. And the main reason why I did that is because the Tinkerbell host has the IP address of 192.168.1.1. And if I would have used the default pod CIDR that aligns with the default Calico network, I would run into collision issues with IP addresses. So I'm overriding the pod CIDR here. And when I deploy the CNI, I'm actually going to deploy Cilium instead of Calico to avoid that. And I'm also telling it only one control plane machine right now because we don't yet have HA support yet. We need to introduce something to provide load balancing before we can actually introduce that, because we are talking about physical infrastructure here. And I also told 0 worker machines because I've only defined that one piece of hardware along with that version 1.18.15 Kubernetes cluster. So if I come in here, kubectl get cluster API, we can see that we do now have a Tinkerbell machine. And it's assigned to that A instance, the only hardware that we've defined. So let me go ahead and turn that on. So at this point, hopefully it'll come over, but as the hardware comes up, we'll actually see it go through a few different steps. The first step is it's going to PXE boot into the boot service, and it's going to retrieve what we call a operating system installation environment. So it's going to download that OS image, PXE boot off of that, and then it's going to start executing the workflows with the Tink worker. So while that's going, what I can do is I can show the actual Tinkerbell resources that got created here. So if I do get Tinkerbell here, and if I can spell, we'll see that in addition to that hardware I defined, there is also a template and a workflow that's defined now. So if we take a look at that workflow, and I am not typing very well today, so I apologize for that. We can see that, let me find the right part. Where is it? Come down. We can see here in the spec how I mentioned that a workflow just ties hardware to a template, and that's basically all it does. And then in the status, we see what actions are defined for that particular workflow by applying that template to that hardware. And we basically have 3 actions here. The first one is basically this image to disk action. And this is basically telling it just take this gzipped image that was built with the image builder and write it to the dev MMC block 0 device. And that was pulled directly from that hardware information that was defined. So if I was using different hardware that would target a different disk, it would write to the right device. The second action that it does here is basically a write file action, and it's writing a file to extend the Cloud-init configuration. And what we're basically doing here is telling it to use the EC2 metadata data source, and we're overriding the metadata URLs. And this 169.254, 169.254 is a link local address that I previously configured on the Tinkerbell host, and this port 50,061 is associated with the Hegel metadata service. And I'm also telling it to use strict ID false, and that's because Hegel isn't an exact replica of the EC2 metadata. So this is just telling that data source, if it doesn't look proper, still go ahead and finish the bootstrap process. Without this, Cloud-init would actually fail. And I'm also overriding the default user. So if I wanted to, I could extend the cluster template that I applied and actually apply a particular SSH key to access the host or override the password or things like that. And the final action that's run after writing that configuration to disk is this kexec action. And this is basically just telling it to go ahead and kexec into the kernel that's associated with that image that I just deployed there. So there's no need to wait for the hardware to reboot. it'll automatically just bootstrap into the Linux environment that we deployed to disk. At this point on the hardware itself, we've already PXE booted into the operating system installation environment, and we're running the Tink worker. It's in the process of streaming that image to the disk. This hardware is a little bit slow, so it takes a little bit. Now it's running the rest of those, and now it's starting to kexec into there. So now we're getting to the point where we're actually getting ready to bootstrap the Ubuntu system and run Cloud init that was defined through the user data. And like I said, this hardware is a little bit slow. So here in a second, we'll actually see the output come to disk of it running the kubeadm init command. But while it's doing that, I can go ahead and fetch the kubeconfig. So let's do that. And as soon as that Cloud init runs, then I'll be able to actually work against that cluster. Yeah, because if I did it now, oh wait, it is running at this point now, it appears. All right. So now it's completed. I have the node, and as per usual, if I deploy CNI, as I said, Cilium in this case, within a short while, as soon as that pod becomes available, the pods for Cilium become available, the node status will change to ready instead of not ready. Then at that point, I could apply the definitions for the additional hardware that we have. I could scale up the machine deployment that we have, and I could basically do all of the standard actions that we expect from Cluster API. If I had some more advanced hardware with some type of IPMI capabilities, I could leverage the PB&J component of Tinkerbell to automate the power cycling of the hardware instead of having to basically reach over and power up and power down. And I know there are other things on the agenda, so I don't want to take up too much more time. And I also want to allow for any questions that anybody may have as well.
So first of all, thank you, Jason. This was awesome. Really a lot of stuff there. So I see there is a question in chat from Jerry.
Hi, everyone. This is Jerry. I'm just curious, there's any way we can assign like a IP address to the Kubernetes cluster in the template? So in the corporate environment, usually the IP address need to be like a reserve.
Yep. Yeah. So yes, there are definitely ways that we can enable that. At this point, we've basically relied on the IP addresses are basically pre-assigned on the defined hardware in Tinkerbell. So when I predefine the hardware, each hardware piece of hardware has its own dedicated IP address right now. It wouldn't be too difficult to wire through a system to where you could specify unused addresses, and we could have the Cluster API provider update the information for the hardware to have that IP address and leverage it that way as well.
Okay. So was there any entry in the cluster like template file? Was that one be able to like assign it there, sort of hard code it, maybe?
Not today.
Not today. Okay.
Yeah. Like I said, right now we expect the hardware to be predefined in there, and we're letting Tinkerbell just manage the IP address management right now. But that's something that we could add in the future for sure.
Okay. Thank you.
Yeah. All right. And thank you all. If anybody has any more questions, I'll pop some more resources into the notes. Otherwise, just reach out to me. Thanks.
Thank you again, Jason. There are votes for the Oscar for the best name demo for you. So, and Yeah. So I try to take back sharing in the meantime. I have a quick question for you, Jason. For my knowledge, is this project